Okay, we're looking at a series of problems, kind of wondering which one might be the easiest one to do. They can be deceptive, and sometimes they look easy and they're not so easy. I'm going to look at number 5 first. It looks numerical in nature. And just looking at it, it's writing it down. Pretty simple. It's 1 plus 2 plus 6 plus 24 plus n factorial less than or equal to n cubed. All right? So it's going to be, let's see, 33 plus n factorial less than or equal to n cubed. Well, I'm going to just start writing the factorial numbers down. Again, I'm going to concentrate on positive integers. So, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, n equals 6. And, I'm not going to do too many. I just want to go through a few of them. And I want to put a column down of n factorial and a column down of n cubes. Well, let me do the cubes first. Pretty easy to do, right? 1, 8, 27, 64, 125, and let's see, 36 times, I don't even have to go there. Let's take a look. N factorial, right? 1, 2, 6, 24, and 5 factorial is 120, right? And then 6 factorial is, 7, let's see, 600, 120, 720, right? Maybe we'll do 6 cubed. 36 times 6, that's 36, right? Because 6 times 6 is 36. And 6 times 30 is 180, and that's going to be 216, right? All right, I think you probably know I want to look at this over here and start talking about these things. 33 plus 1 is not less than or equal to this. 33 plus 2 is not less than or equal to that. 33 plus 6, that's not less than or equal to that. 33 plus 24, that's getting more complicated now, right? 33 and 24, 37, 47, 57. Well, this one appears to work, all right? Now, 33 plus 120, right? 33 plus 120, no, that's not going to work. And I hope you realize that these things here, they grow really fast. So none after are going to work. So only one works. And what's that number that works? N equals 4. All right, let's take a look at the key. I'm going to go to number 5. Oops, went too far. How many positive integers satisfy the inequality, blah, blah, blah. We were at the inequality. I did that part. I went through some of the numbers. 4 is the only thing that yields a solution to the problem. It talks about the growth of the factorial there. Yeah. All right. So we did okay with that. We just did it by looking at some, some simple numbers over there. Let me erase. And I'm going to start to look at other problems here. And again, you may disagree with what looks easy and what looks difficult. That really is a personal choice. All right, a personal choice. All right, I'm kind of looking around. I think one looks easiest, but I'd have to go through a derivative because it looks like L'Hopital's rule. 2, I don't know, a lot of manipulation there. 3 is trigonometric. I'm going to try 4. I want to do something here that might seem a little bit strange to some students. I'm going to look at, I'm going to just count everything up. And it says over here in the figure, the large equal triangle is composed of 25 smaller ones. So, the smaller ones, let me just shade one of the smaller ones in for you. Like this is a small one over here. And they say there's 25 of them. Let me just go through the counting of it for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there's 25 of these small triangles. Let me get my eraser out. And each of those equilateral triangles has an area of 1 centimeter squared. Right, I see that right over here. Their question is this, though. What's the area of ABC in centimeters squared? So what I'm going to do over here is I'm going to kind of look at it, and I'm going to break it up into smaller triangles. And what I immediately notice about this, let's take a careful look at this. I'm going to look at it carefully, right? And I'm going to break it up. And let me just get maybe some different color here, right? And I got this one over here now. And then I got this one over here. All right, so let me, I'm going to kind of shade them in now. So this yellow guy here, this green guy here, and then the blue guy over here. I'm looking at it. I think I could do this now. So I'm going to draw a triangle like over here now. Let me use black. Right now, looking at that, that is the same area as that yellow one. All right, now let's look at this one here. And I gotta be real careful about this, right? I'm looking at this one now. And I'm saying that one is the same area as the blue one. Let me see if I get the green one going. I think I can. Gotta be careful. I gotta look at it. And something like this. And that's the green one. All right, now the area they want is the that ABC. So I'm going to say, I'll write this down for you. I'm going to say the area of the blue, right? I'm going to call it A. Let me get my eraser out. The area of the blue plus the area of the yellow plus the area of the green plus 1 is the area they want. All right, let's take a look. And I'm going to look at this. So let me do the whole picture. The whole picture is 25. And how many blue areas would I have? I'd actually have 2. How many yellow areas would I have? I'd actually have 2. Right? I have 2 yellow areas. And I'd have 2 green areas too. Let's keep going. But that doesn't give me everything, does it? So what's missing over there from that full picture? Well, a bunch of equilaterals are missing. So there's one here, one here, one here, one here, one here, and one here. That's going to be 1, 2, 3, 4, 5, 6. All right, let's see what we get over here. Let me count that up again. 1, 2, 3, 4, 5. Oh, I forgot this one. That's actually 7. Let me just make sure you know what I'm doing over here. I'm counting up the missing ones. 1, 2, 3, 4, 5, 6, 7. Let me get my eraser out. And I'm going to be careful here, right? All right, let me make sure I got this thing right. There's 2 of the blue areas. I'm going to shade that in for you. These are the 2 blue areas, right? There is 2 of the yellow areas. Now, let me just shade that in for you. It's this over here. And there's 2 of the green areas. I'm going to shade that in for you. And then there's some missing pieces from the full 25 pieces. And let me just make sure you know what I just did. I did 1 there, 1 there, 1 there, 1 there, 1 there. And that's going to be the 7 pieces. Let me shade those in for you. There's 1, 2, 3, 4 there, 5, 6, 7. So I counted for everything. It should be 25. And I do have 25 down. So I'm going to take 7 from both sides, and they get 18 equals 2ab plus 2ay plus 2ag. I'll divide both sides by 2, and I would get 9 equals the area blue plus area yellow plus area green. And now I know it. The area that they wanted is simply going to be 9 plus 1, which is 10 centimeters squared. All right? So that was a visual problem. All right? I'm not going to say it was easy to do, but especially keeping track of things and counting, things like that. But let's take a look at the key. That's number 4. Number 4, a lot of work there, isn't there? Yeah, I see the answer. All right? So I'm all right. You should read over that too, by the way. Let me start to erase. And so I got 2 down. I just did 5 and 4. And now I want to do another one. I did 5 and 4. And I got 3 more to go, right? Let me do number 1. It looks pretty easy. However, if you can't remember things, nothing's easy. I'm going to say L'Hopital's rule, and the limit of the top is going to be 0, and the limit of the bottom, the natural log of 1, is 0, and then 1 minus, it's L'Hopital's rule. So limit x goes to 1 from the right side. I got some troubles over here. I'll tell you what my troubles are. What's the derivative of x to the x? Well, let me write this down for you. I would take the natural log of both sides. Then I would differentiate. This would be 1 over y, dy dx equals, well, it's going to be a product now, so it's going to be x times the derivative of the natural log, which is 1 over x, plus ln x. And so dy dx would equal y, which is x to the x, times 1 plus the natural log of x. And I needed that, by the way, because I have to do this. And I'm hoping things are going to go smoothly. If not, I have to rethink the problem. So what do you get? On top, you get this. X to the x times, I'm taking the derivative of the top, 1 plus the natural log of x minus 1. On bottom, its derivative is going to be minus 1 plus 1 over x. All right, let me just check my work right now. I did natural log of both sides. I got x ln x, 1 over y dy dx, x times 1 over x plus 1 times ln x. Y is x to the x. Yeah, I think I did it right. I'm looking at it though, and I'm wondering what to do now. And let's see, the bottom's still 0. And the top would be, that's 0 too. Let me get my eraser out. I'm going to erase this business over here, okay? That's a derivation. I don't need that anymore. All right, let's take a look and be careful about this. Well, I'm going to write this thing over here a little different. I'm going to write x to the minus 1. And I think I might want to use L'Hopital's rule again. Limit x goes to 1 to the right. The bottom is going to be minus x to the minus 2. And the top, let's write this down. It's the derivative of x to the x, which is x to the x, 1 plus ln x. Now it's going to be times 1 plus ln x squared. Let's see, plus x to the x times 1 over x. Well, let's look at that. I think I can handle that one. Let's write this down now. The bottom is going to be minus 1. And the top is going to be 1 plus 1, which is 2 divided by minus 1, so minus 2. All right, let's take a look and see how we did. Yeah, and they used L'Hopital's rule twice. All right, so we did okay with that. And I'm going to look at the other ones now, and they're a little trickier, though. I'm going to erase this work over here. Again, we're just covering what's in the blue area. And again, I hope when you're doing these problems, you're using a lot of paper. I know I'm sort of like, that the teacher had a really small whiteboard, and all they're doing is what they can fit in the whiteboard. So I'm going to do number 2. All right? Actually, number 3 doesn't look that bad right now. So real number theta satisfies this. What is the value of? So a real number theta satisfies this. What is the value of? Now, let me write this down. I'm going to work with this. And this is really cosine theta equals sine theta over cosine theta. And this really translates to cosine squared theta equals sine of theta. Well, I guess I could write down cosine 4 theta equals sine squared theta. see what I could do now. Cosine 4 theta equals 1 minus sine, no, not sine, cosine, sorry about that. And let's do this, cosine 4 theta plus, I'm looking at this now, see if this actually helped me out. Cosine squared theta would be sine theta. So 1 over sine theta you know what, I'm going to jump ship on this one. Just because I'm not really seeing something that's leading to where I want to go. I'll come back to it. This is important. I want to go this one up here. And what I'm going to do over there is just, they say for real numbers A, B, and C, the polynomial has 3 distinct zeros. I'm going to write the zeros down as, let me write this over here for you. The zeros for this one would be R1, R2, and R3. And what they say is that they share these with the other polynomial, but the other polynomial is degree 4, so the other polynomial is going to have R1, R2, R3, and R4. I want to point out they're shared. These are shared. All right, so what do I know about this? And let me write this down. Now I'm going to erase this because I can keep that in the back of my mind. So I know that this guy over here, I'll write this down for you, is going to factor to x minus R1, x minus R2, x minus R3. And this one here is going to factor to x minus R1, x minus R2, x minus R3, x minus R4. Well, what I'm going to do is I'm going to divide f of x by g of x. And let's see, that's x cubed plus a x squared plus x plus 10. And I'll divide this over here. X minus R1, x minus R2, x minus R3, right? And what's nice about this over here, that there are a lot of simplifications going on here. I'm going to say that these are going to cancel off. And what are we left off with? I'll write this down for you now. We're left off with x4 plus x cubed plus bx squared plus 100x plus c. And on the right side, you're left off with x minus R4 times this thing. Let me write down for you. X cubed plus ax squared plus x plus 10. All right, let's keep going. And what I'm going to do is I'm going to equate coefficients now. And someone says, what do you mean by that? I know there's coefficients over here. So it's really, I'll write this down. It's x4 plus x cubed plus bx squared plus 100x plus c. And I'm gonna write this down now. So it's gonna be x4 plus ax cubed plus x squared, right? Plus 10x. I'm going to do this one now. All right, so what's that going to be? Let's call that R4 just R now, because it's too tough to keep writing that down over and over again. I'm going to erase this. Whoops, I did a big erasure over there, didn't I? I'm just going to call it R now, okay? All right, let's write this down now. So what are you going to get? Minus, whoops, minus R x cubed minus RA x squared minus RX minus 10R. I'm going to equate coefficients together. By the way, I hope you realize that x4 does equal x4. This is not my issue over here. It's the x cubed. What's coefficient x cubed? It's 1. What are the coefficients on the right-hand side? It's A minus R. All right, so I'm just going one term at a time. Let's do the next one, which is B. What's B going to be equal to? Well, that's the square term, right? That's going to be 1 minus RA. All right, let's do the term with the x, right? So it's going to be 100 equals 10 minus R. Right, 10 minus R. Last but not least, we have the constant term, which is C, must equal minus 10R. Well, this one, I think I know what this one's going to be, right? So if you look at that, the R would have to be minus 90. And if the R is minus 90, I think I can figure out the C. What's the C going to be? Well, it's going to be 900. All right. I got to work my way backwards now, don't I? So I know the R is minus 90. So I think I can figure out the A now. What's going to be? It's going to be 1 equals A minus R, which is plus 90. So I'm going to say the A is going to be minus 89. All right. I think I can figure the B out now. So the B would equal 1. That's going to be plus 90 times the A, which is minus 89. All right, let's put that down, all right? Let's see. 90 times 89, right? Let's see, 9 times 9 is 81. 9 times 8 is 72. 72 and 8 is 80. So 8010. So it's going to be 1 minus 8010, which is minus 8009. Gee, I hope I didn't make any mistakes in the arithmetic. So let's see what we got over here. And what was their question? So I don't even remember what their question is. Their question is, right, what's f of 1? Well, let's write this down. F of 1, I got to be real careful now. F of 1 is going to be 1 plus 1. Now what's B? It's minus 8009 times 1 plus 100 plus C. And C is 900, right? Wow, these are crazy numbers, aren't they? So I'm going to say 1002 minus 8009, which is going to be minus 7007. Gee, I hope I didn't make a mistake with the arithmetic. That was a lot of work, right? So that's number, what number is that? That's number 2. Oops, went too far. Yeah, right there. We didn't make any mistakes with arithmetic. All right, so that wasn't that bad. I don't enjoy the arithmetic, though, I'll be honest with you. So I'm going to erase that. And, you know, certainly if this is a competitive exam, I'd be a lot more nervous, of course. But what I'd claim is that I'd want to go back to that problem I futzed around with, right? So I'm going to go back to it, and I'm going to look at it. And let's take a look. And I'm going to go back to it. And let me take a look. I'm going to try again. Whoops, sorry about that. Let's try again. Cosine of theta equals sine theta, cosine squared theta equals sine theta. Did this last time too, right? There's something a little different now. I'm going to put down, let's see, 1 minus sine squared theta equals sine theta. And I'm going to, a real number theta satisfies this. What is the value of? Oh boy, let's take a look now. So I'm going to say this is 0 equals sine squared theta. All right, let's keep going. Plus sine of theta minus 1. I'm going to do something that probably you're going to find a little bit odd, but I'm going to try to solve for sine theta. There's a number here that would satisfy that. And I'll write this down for you. The sine of theta. This is almost like a quadratic. It is a quadratic. I'll write this down over here. All right, it's going to be a little bit tough though, right? So the sine of theta would be what? And by the way, I want to get the key word here is real. Let's see, twice the a, that's 2. It'll be minus 1, that's coefficient on the linear term. What I mean by that, I'm almost seeing this as the quadratic of u, and this would be u squared over here. So let's take a look. Plus or minus, let's see, 1 minus 4 times 1 times minus 1, so plus 4. So sine of theta is going to be minus 1 plus or minus the square root of 5 over 2. But you know what? One of them doesn't make sense, and I'll tell you why. The sine of theta for a real number system has to be between plus or minus 1. So if I wrote this one over here, right, that's going to be minus 1 minus a number bigger than 1, so it's definitely that's out of range. So I can only accept this one over here. All right? So what do I have to do now? Well, I got to figure, I got this part done. This part over here is just this over here. It's 2 over root 5 minus 1. So this part's done. But I don't have that cosine 4 yet. So the way I'm going to do that is I'm going to start to square this thing. So sine squared theta, and again, this one is the one we're using over here. I'm not using the minus root 5. Let's square it. All right? Let me put a little box in this over here indicating this is important to me. When you square that, what do you get? Well, you get 4 in the bottom. And on top, you get 1 plus 5 minus 2 root 5. Well, I got to simplify that because I have to do something with it. And what's that going to give me? That's going to give me 6 minus 2 root 5 over 4. And that's a sine squared, by the way. And that's going to give me 3 minus root 5 over 2. Let me see if I did that right. Yeah, I think so. And that's sine squared theta. But really what I wanted, I really want the cosine. And so the cosine would be 1 minus cosine squared. That's what sine squared is, right? And this would be 3 minus root 5 over 2. So I would get 1 minus 3 minus root 5 over 2 equals cosine squared theta. Well, that's a lot of work, isn't it? So this is going to be 2, common denominator, and you would get 2 minus 3 plus root 5 would be what's cosine squared theta. And what does that give you? That gives you root 5. Let's see, minus 1 over 2 would be the cosine squared theta. Now someone says, you didn't want that, you want the cosine 4. Well, I can do that now. So cosine 4 theta would be, let's square that number. What do you get in the bottom? 4. On the top, you would get 5 plus 1 minus 2 root 5. I got to simplify that. And that would give you 6 minus 2 root 5 over 4. Or this would turn out to be 3 minus root 5 over 2. And this is what the cosine 4th power is. So 3 minus root 5 over 2. Let me make sure I copy that right. Yeah. I got to do the arithmetic. And let's do it one step at a time. And I'll write this over here. 2 root 5 minus 1 times root 5 plus 1 plus 3 minus root 5 over 2. Let's see, you would get 5 minus 1, which is 4. And I'm going to cancel with a 2 on top, so it would be 2. And you get root 5 plus 1 plus 3 minus root 5 over 2. Let me just check this before I go forward, though. 5 minus 1 is 4. 2 into 4 is 2. Root 5 plus 1. And yeah, it looks like it's coming together. And you're going to get 4. And let's put this down. This is going to be 4, right? When I add those together, over 2. Lo and behold, we got a nice looking number 2. Now, granted, maybe I made a mistake in computation. What number is this again? That was number 3. And I'm saying the answer is 2. Boy, a lot of work. I got the 2, though, right? Now, granted, I do it a variety of ways over here, and I can't say one way is better than the other. Don't ever think that I think one way is better than the other. People do make judgments, though. And sometimes, you know, I make judgments, too, when I see someone do something. I say, are you crazy doing that? And I don't think it's really a fair thing to say. It's the way it was done. And, again, there might be 2 different ways to do it, 3 different ways to do it, 4 different ways of doing it. Maybe you see something I don't see. It can happen, all right? But anyway, it's nice to be able to see what other people did to do the work. But I do want to encourage you, you know, you take your own path. But the path here is 2. It leads to 2, all right? Okay, so I'm going to say of those problems, let me go back and review with you. You know, looking back over it, you know, I really do think in hindsight that that 5 was probably the easiest to do. Basically, just an arithmetic problem. Let me look back over and see what might have been the next easy one for me to do. Maybe the geometry problem. The limit wasn't bad, but I had to figure out a derivative there. This was tedious, though. and this was tedious, all right? But anyway, I do realize that, people looking at my work may not necessarily think that I took the best road there. Or maybe they're confused by what I said. It's possible, or what I wrote down. My name again is Bannon, and my email address is Bannon, which is B as in boy, the @ symbol, NNON.US. And that's my email address. Now, granted, I can't imagine these documents becoming popular, but who knows? But I would say this, if you're reaching out to me and I'm not overwhelmed by a bunch of emails, I'll get back to you. I will. If you have something constructive to say, I might add it to the notes. I might add it to notes. Right now, the people that have access to these notes, though, are the participants in the prison mathematics project. All right? They're the only group that has access to it. But here's the deal. At some point, I'm going to have to release it to everyone, and these are just a collection of problems I've collected over time. All right? They're not, and certainly, especially people that spend a lot of time, looking for problems, you might have seen a lot of these problems before. They're just rehashed problems. You see a lot of problems in competitive mathematics are just rehashed problems. All over YouTube, you'll see rehashed problems, people solving problems. Sometimes I notice when I'm watching YouTube videos, though, people are solving problems, and they're really taking, what I consider, they're making pretty bad choices in solving the problems. And there's a problem there. Some people might say it's really difficult. There could be easier ways to do that. That's what I'm trying to encourage you. Please reach out. If you see something easier or better, let me know, all right? Let me know. And you just reach out to me. Again, thanks for paying attention. I do appreciate your time.